Hello, my name is Ian Bird, and this is my presentation on magnetic nanoparticles, the solution to microplastic pollution within our environment. To begin, defining a problem is the best way to get to our solution. Microplastics are man-made particles that cannot be dissolved by any means, collecting with environments around the globe, and they get the micro part of their name for being 5 or less millimeters in diameter. Microplastics can be traced as far back as the 1900s, where after the creation and subsequent implementation of Bakelite, it was discovered to have accumulated within the ice caps, sparking a worldwide shift in fear of this discovery. So microplastics are an offshoot of our creation and consumption of plastics. It's important to recognize that when we litter or improperly dispose of any plastic-comprised product, we introduce this indissoluble hazard into the environment. If it wasn't apparent, these plastics are quite small, small enough to find its way into almost everything. This can be the soil, plants, animals, and humans. And as it's already been proven through countless researches, microplastic interference with life and its environments is proven to be problematic at least and detrimental at worst. For example, microplastics can interfere with water purity, lowering the light level of several photosynthesizing aquatic life forms, preventing them from producing carbon, a necessary ingredient to further life cycles within the ecosystem. Or how it can accumulate within plant roots, clogging their organs, which severely hinders their ability to grow, create edible produce, and reproduce amongst themselves. For reference on how small they are, the human jugular vein ranges from 8 millimeters to 15 millimeters. Now that we have defined what our problem is, and more importantly why it's a problem, how do we fix it? Well, our solution is called magnetic nanoparticles. These are a synthetic creation, and unlike microplastics, are comprised of magnetic elements, such as iron, nickel, cobalt, and specific steels. Specific magnetic nanoparticles also include using oxides called magnetites and macamites. These, like microplastics, get their name nano for being within 1 to 100 nanometers. We know they are effective because we've used, tested, and proved them. A specific magnetic nanoparticle called Fe304 at AC has a successful microplastic removal rating of within 60 to 100%, with an efficiency level of 80%. This magnetic nanoparticle can also be reused upwards of 5 times, with each use having a lower removal and a lower efficiency rating as it gets reused. Similar magnetic nanoparticles can also see similar successes within time frames as little as 6 hours. So, they're effective, successful, and work quickly. But how do they work? Well, we utilize things we already know, like the composition of microplastics and the naturally occurring forces that brings atoms and molecules together. But before getting into how magnetic nanoparticles work and how we utilize those known forces, 2 definitions of the processes that occur will make it more cohesive. Pore filling. Due to the surface of microplastics being uneven and rough, small holes or divots are created and can be filled. When they are, that is pore filling. Van der Waals forces. This is the forces between atoms and molecules that drive them together. Here's the explanation. The way magnetic nanoparticles erase microplastics is that when introduced with each other, they undergo pore filling, which temporarily magnetizes the microplastics as well as the magnetic nanoparticles once they fill the divots with magnetically charged particles. This is also furthered by the van der Waals forces, which further binds the microplastics to other microplastics as they get pore filled as well. After being bound, these microplastics can be removed from the environment with any magnetically charged filtration devices, or, alternatively, can be dissolved if the magnetic nanoparticles composition includes something that can erode the microplastics, allowing the microplastics to be filtrated through natural means. So here we are. You've defined microplastics, what they are, their history, and why they are a problem. Then we describe magnetic nanoparticles, what they are, their effectiveness, and how they work against microplastics. I hope that this slideshow has given some important and relevant information on the topic to educate, even if it's on a very simplistic manner. Thank you for listening.